Okay, so this is cart problem quiz. So here's cart A, here's cart B, and somewhere up here is pulling. Now let's see, y'all remember what did we know about this? What do you know about this height here? This is part A, B, and this is 12. This doesn't change throughout the problem, right? So we're good to go. Now, if you pull this cart on the path here, it's certainly going to change these lengths, right? So there's a lot of variables here, right? What all can change? What's the smart things to do? Oh, that was something else. So, you know what? I'm going to label crap out everything. I'm going to call this X. I'm going to call this Y. And I'm going to call this A, little A, and this little B. Now, all four of these quantities vary as you pull that cart, right? Okay. And there was something about cart A is being pulled at what, 2 feet per second? So interpret that for me. Okay, so I know, excuse me, when I pull this cart this way, it's changing everything in this picture. Well, what's the direct thing that I do know how it's changing? This right here, right? So when I pull this cart this way, is X getting bigger or smaller? Bigger, great. So it's a positive 2 feet per second. By the way, what do you expect to happen to the Y when you pull the cart A to the left? I expect it to move to the right. What do you expect to be true about dy dt? Positive or negative? Negative, right? Because I expect as I pull this cart, it's going to suck this cart in closer. So I expect the Y to shrink while the X grows, right? That's just kind of ballpark. Sometimes. Okay. What was that other thing that you said? The rope is 39 feet. Correct. Okay, and that's a snapshot. X is not always equal to 5 feet, but it's equal to 5 feet when we care about it in the problem. This is something we should probably not worry about plugging in until after we take a derivative. That's good to know. Critical moment. Quest. The problem asks, what is y t when X is equal to 5? Okay, so I need some equations involving X and Y. I've also got these other variables that seem to only come up here. And A changes and B changes, but their sum never changes. Okay, actually, I'll give you all a hint here. The way I did the problem, I'm not to say that's the only way to do it, but the way I did the problem, I used actually two of them. You see two equations? They come up with X and Y in them. That's one big fat triangle that I'll cut into two, that vertical line. The vertical line cuts into two. What are those two triangles on the left and right? What's special about them? The right triangles. And so with right triangles, I get Pythagoras' theorem, right? So let's do Pythagoras' theorem here on the left. Everybody okay with that? And in a similar fashion, Right. Now, this might be a little bit scary at first, right? Because I'm trying to find out y dt. I know some stuff about the x dt. They seem to be in different equations. Right? But you're not. You know what? I'm going to take a derivative of both of these and see what happens. What's the derivative of this? Derivative of x squared is and this is 2a. Let's do this. Now, what we're looking for is dy dt. Unfortunately, I don't know what y is. I don't know what b is or what dB is, right? Right, and so I feel the tears kind of welling up here, but I do have two equations. Right? And what do I? I know what the x dt is, right? And yeah, that was supposed to be 2. And I know what x is. You know what? I can figure out the a dt from this, can anybody tell me what a is? X equals 5. So how can I use that to figure out what a is? Well, let's go back to this thing right here. So at this critical moment, I know all players are, except for the ADD, which means I figure out the ADD. Right? So let's use this equation. 2x dt. Okay, what's x? X is 5, right? The x dt is 2. A is 13. So figure that out. And that means I can figure out what the is. So this is 2, 5 times 2. 2 times 13 times dt. And so I guess that's what 10 verses. That should be 8%. Well, now what? Obviously, if I am going to find the y t, which is what I'm moving this equation, but I'm missing a whole smorgasbord of stuff. I'm missing, I don't know what y is. I don't know what b is, and I don't know what dB is. There must be some way to figure that out. That is the first crucial step here. Also, at this critical moment, A is 13, so B is 26. Where did that come from? Exactly. Good. So now I've got, let's see, to use this equation, I need to have all these. Okay, so now I've got B. I still need y and db dt. See, now that I've got b, I've got y. How is that? Look at this equation. Once I know what b is. So y squared and this is something like 676. Okay, now I've got y. The last thing I need is to be the t. Right? I figured out what b is. Then I bootstrap to figure out what y is. But I still need to figure out what the dt is for this equation. Any ideas? Let me ask you a question. Do you know what the ADT is? You know what that is? What is that? 1013 feet per second. That tells you what the ADT is. I'm going to do common sense and then I'm going to do purely mathematical. With the ADT 1013, that means that this piece of the triangle is growing by 1013, right? So this triangle is shrinking by 1013. Why is that? Because the length is constant. So if you're gaining ground by 1013 and the length stays the same, you have to lose ground by 1013 here, right? And in case you're not big on common sense, which I never was myself, you can just let the math do it. And here's how. Look at this equation here. A that's my length of road equation. DDT this thing. The A T plus the B T is equal to the derivative of 39, which is 0. So the ADT and the BDT are always opposite in sign. And that, again, that makes sense because the rope has to stay constant length. So if you're going to make this one grow, you have to make this one shrink at the same rate. Okay, so here's the big finale. Let's do this. Equation here. So y was square root of 532. YDT, what we're looking for. B was 26. And the BDT be negative. You know, those two cancel, and I get the y t is equal to 26. This is minus 20 or radical. Yes, what's writing down this? Because from this equation right here, because we know that A is 13, that forces B. Other questions? Any other questions? Is that cleared up for you? Yeah, what else we got? Yes. Is that the airplane? In fact, I'm gonna do this the way I saw some of them do it, which is fine, but. So you've got this airplane. Over. Station. At altitude 3 miles. And 300 miles per hour. We were going to assume just for ease, that the earth is flat. This is not the flat earth society. The earth is not flat. And a little bit of this. But it flies on the station at an altitude 300 miles per hour. How fast is distance between airplane and station? Thing 28%. And we'll see if the same students do. Okay, first thing, draw a picture, which many of you did pretty well. In fact, in some cases, some of you grew a really nice looking station, shirts and grapes, very, very kind of fashion. Don't make anything too fancy, just make it a point, right? I used to try to make my pictures fancy too, which is, let's simplify it, right? Here's the station, right? And here comes the airplane cruising over the station like this. What can I label so far? And what is the altitude? Does that change throughout the problem? It does not. You are correct if you label this 3 miles. Now, one of the things that I told you about, some of you labeled this something like Y miles. Nothing wrong with that. I can't argue with it because it's correct, right? But you did kind of mess yourself up later. But I'll show you how to do things. So here is, what else should I label for house? Right. It's hard for me to label speed, so I'm going to label distance here. I'm going to call this X. And that's how far the plane has gone, traveled from being on the station. And since I'm talking about a distance from the station to the plane here, maybe I should call this S. Okay, so let's get the information on the problem. 300 miles per hour. What's that all about? Agree. And this sucker, it's growing. It's probably 300 miles an hour because as the problem goes, it grows at that rate. And what's our quest in this particular problem? What are we looking for? I agree. I'm Quest. Seconds later. Maybe I should make that a little bit better, because nowhere on my diagram is there 48 seconds later. Right? I've got to put that in terms of something that I wrap my head around. By the way, what do you suppose the translation is? This is for some time. I want to know how fast the distance is changing 48 seconds later. But in context, what do you think I'm going to have up here? What's the translation on the chart? So what I want is this 48 seconds. I want to translate this into either an X, a Y, or an S. It's probably not Y because it doesn't change. Yeah, but your units are wrong. Because remember, the S and the X, they're measured in miles, right? So you can't add them to a second, right? So how am I going to use this 48 seconds? Okay, I think it's so. Let's do this. 48 seconds is equal to 48 seconds. 60 seconds is 1 minute. So this is equal to 4/5 of a minute. I agree with you. And I guess we should convert this on to hours, right? Times, let's multiply this by 1 hour is what, 60 minutes? So this is 1/75 hours. And the point of her changing our units for us, so we can use that to figure out what X is. Right? So this translates to 300 miles per hour times 1/75 hours. This is well, let's just see. Yeah, it's 4 miles. Right. Okay. So we're looking for the SCT actually when X 4. So what do we got here? I know a DXCT, I know an X, and I'm looking for a DSCT when X is 4. So this strongly encourages me to get up some kind of equation here that involves both X and S. What do you see? Right? Because this is always 3. Now, here's what some of y'all did, and I'll tell you, it comes out okay. So what I saw some of y'all do is this. You made it a little harder on yourself. At the end of the day, you felt them out. Right? I mean, that's certainly true. You call it y. Everybody agree with that? Now let's take the derivative. What's the derivative of x squared? 2x times derivative of y and s squared. Now, if you notice, if I'd taken the derivative of this, I would have just got 2x dx and 2x ds. no one gets still term. But it's all taken care of because what is divided to? Is zero. Y is not changing at all. It's a big fat zero. So you actually get more Fremont, now cancel two, x dx t is equal to s ds. But now let me go back and review. You see, we're looking for the s and t. I've got x. I've got the x and t. I do need s, right? So let's go back to the well. Then x is equal to 4, and s is equal to anybody know what it is? Oh, you're close. Yeah, it's actually 5, because this is 4 squared, which is 16 plus 9. Okay. So let's put it all together. X is 4. The x to t is 300. 5 the s to t. So if you divide out by this, I get the s to t is 240 miles per hour. Does this seem to make sense? The x to t is growing fast, right? So if you were standing here, you would see the plane moving away at 300 miles an hour. Here, you see it moving away not quite as fast, right? Because it's displacement. Yes. I would really, on any one of these related rates problems, if it's at all possible to draw a picture, draw a picture. Label it clearly, right? And then I would literally, it may seem childish, but I would seriously, I would go through the problem and kind of collect the information like we did. Okay, what does this 20 miles an hour mean? It's dx to t, or whatever it happens to be. Organize it there, and if you like, you can talk to me about that later and see if there's something. Yes. Oh, from this. Well, your next 40 is 16 times 25. So that's where it's 25 cents. Okay. Yes. What was it? You can do whatever you like. or for somebody else, and question that. Whatever you need. Yes.
Change this, but
Oh, you want me to? Here's what I got. So the question is, do this derivative. Oh, that was great. I read it. What they need is estimates and derivatives. I can look at it. So let's try to go through this. This problem looks intimidating, but it's actually easier than it looks. Somebody explain why. I've already got a log there in the first place. Let's take advantage of it, right? So before I take a bunch of derivatives, let's do this. This is log sine x part of the cube plus log x fourth plus 2 log x 1/3 power minus log e to the 7x minus log inverse sine of x squared. Okay, does everybody understand that first step? And I actually want to another step. Make it even easier. All these exponents I can bring down. This is 3 log sine x plus 1/3 log x4 plus 2 log x. And this is just 7x, isn't it? Right, because even 7x log is expected to be 7x. And this is minus log.
I had a question.
Yeah.
So I have the actual problem here, and it doesn't look like that's why it's under like the slides.
Oh, okay, yeah. Well, what I'm doing is correct for what I wrote there, right?
Okay.
But if the natural log of x is outside of the problem, and that may have been some of your problem exam, you copied it down wrong, but then there'd be an extra log x. So what I'm doing is correct for what I've written. Everybody okay? There's one piece that I think is hopefully familiar from check here. Anybody, I'm gonna need this. Anybody remember what the inverse sine is? derivative inverse sine of log of 1 over the square root of 1 minus log. Okay. So let's do this. Okay, 3 derivative log of sine is 1 over sine x times what? Thank you. Sine x. 1/3 log of log 1 over log times, in this case, 4x cubed plus 2 over x. So derivative x4 is 4x cubed, derivative 2 log x is 2 over x. Ooh, I can do derivative minus 7x. 7. And finally, 1 over inverse sine of x squared times the derivative of what's inside. 1 over, you'll show me this, 1 minus 4. 1 over 1 minus log squared, so 4 times what? The derivative of log in this case is 2. Get a complete answer, and that's the complete answer. Once you're done with the calculus, don't do like you do on Jeopardy, try to answer the question too much and get it wrong. Let it, that's right. So you're in this class, I assume you know how to do algebra. Don't spend test time trying to prove me wrong, okay? Just leave that alone. You should only simplify or do algebra if there's something into it, something in it for you. When we get to curve sketching, sometimes you'll need to simplify some things to figure out roots and stuff like that. But here, when I'm asking derivatives, just do the calculus. Yes, so the natural log of 7x, 7x for the natural log. Natural log b is 1. That's right.
When you move the 1/3 down, is it like it's supposed to have like negative third or something like that?
No, I'm not taking a derivative. I'm using the property of the log.
Okay.
Right. So I'm glad you asked that. There's no calculus here. There's no calculus here. I'm using properties of logs. This is the calculus.
So I'm doing it. That's a lot outside. So when I have it, that's a lot.
So your question is this. How do you do that? First thing you come to, natural log of log. What's the derivative of natural log of log? 1 over, there's log. Now you're inside the parentheses. You got to multiply by the derivative which you find inside there. The derivative of log x, 1 over x. And then derivative of x. So it's 1 over x log x. Yes, sir. So we usually work this. This is still a test or something. Summer 2017, which one? This one, but I just keep picking it out. Choose it. You could do that. Yeah, you could do it that way if you so desire. But I think there's a better way to do it. So this is this is an old exam problem from summer 2017, I think. So the one of this. I'll do this two ways. What's the last bit? It was the sign. Do I have that right? Okay, I'm gonna do this two ways. In fact, it might be just four. Good. First thing you come to, e to the block. Right? What's derivative of e to the block? E to the block. I love it. So there's the first step. And now you're inside that first chain. So I got to multiply by the derivative of what I find in there. And what do I find? Another stair stepping exponential. This is an e to the block. It's derivative of that. E to the block. And now I work my way inside this parentheses. Multiply by the derivative of what I find inside there, which is e to the block again. It will not this, I guess. Then I'll work my way inside. Here's what I find inside there. Here, sine of x squared. What's the derivative of sine of block? And I'm going inside my final chain. Now, you could do this log. This particular one, because it's an exponential and it's, I don't really recommend it, I don't think, but so now I have a log of f of x is I'm still digging. Now at this point it's quite familiar, but you know, I'm just going crazy for logs now. So at this juncture, the log itself is very useful. But now I can differentiate implicitly. So derivative of log blob is 1 over blob. Times the derivative of what I find inside. What do I find inside? I find log of blob. Times the derivative of what's inside, and I find log of blob. Times the derivative of what's inside, so let's have to find this. Alright. And the other side is just the derivative of sine of x squared, which is cosine of x squared. Alright. So I can solve this actually for f prime of x by shoveling all this crap over the other side. So f prime of x is equal to f of x log f of x log f of x times cosine x squared of 2x. And now, write down everything we had before. Let's go through this. F prime of x. F of x is this thing, e to the e to the e to the sine x. Sine x squared. So that takes care of that. Log of f of x is right here. It's e to the e sine x squared. Log of x, f of x is right here. And then I get my cosine x squared. And it should be the same thing I got here. That's the great thing about math. As you get more and more proficient with it, there's usually multiple ways to skin a cat. So it's often, if you've got time on your hands, you can check yourself by doing problems. Okay. Other questions? Oh, you want to derivative of that? Okay, folks, how do we take derivative of this? Would you have much trouble with this if this was an E instead of a 2? That would be easier for you? Okay, so let's make that because. So, remind me of this. Remember what this was? Mm-hmm. A to the x times the natural log. Notice the natural log of b is 1. So here, this is a chain rule, right? Because there's my blob. And here, the role of A is being played by 2. So let's use that formula here. Y prime derivative is 2 to the blob times natural log 2. That's what the derivative of 2 to the blob is 2 to the blob natural log 2. But am I done? What do I got to multiply it by? derivative log, which in this case is that makes sense. I will. Here's another, I'm gonna do the process. How many of you, yeah, how many of you sort of got this? Right, that's very easy. I can think about this too. How many of you know what the formula for E to the X, right? Derivative E to the X, E to the X? Well, here's how you can save your butt. If you, oh God, I can't remember what it is. Here's what you do. Your problem is you don't remember what the derivative to the X. Take a log of this. And this again allows me to slide that power down. So calculus that. Now you've got nothing to worry about, because even though there's a log there, log 2 is just a number, no different than 4 or 10 or 76, anything more. So let's take the derivative here. D dx. This is 1 over y prime. Right. And the derivative of this is log 2 times the derivative of what's inside, which is cosine x. So we should cover our formula. Y prime is y times this mess here. Cosine x log 2. And y was whatever y was 2, 3 plus sine x. Times natural log 2 cosine x. And this is one of the myriad reasons why I said, you know, the principle, once you understand the exponential function, and once you understand the natural log function, it really eliminates your need for other bases. Any questions? Yes. Well, so what is H? H is the I think it's not. Actually should be whatever G or Y, whatever this is. That's actually the X is 5. Yeah, so whatever this letter is, that's 5. Yeah. H is how high there is. Yeah, there's some stuff that's like mispronounced. But this here between each chain, it's not. Yeah, so the plane is not constant, it's moving, but speed is constant. Throughout that. And its height is always constant, right? So the H should go. Did you understand when we looked at the line? Yes, this number is. Seven over six. If this is your answer, this is all the it's close to 14.6. For like 7/3. So it's like 2 1/3. And the actual answer. That doesn't matter. So it's a simple process. So I did. So here it is. But this is all. Something. Yeah. That's perfectly. No, this is always three. So lots of people. I think that middle station. You know, everything shows up on that. Make it easy. And that'll correct the system. So it's doing the input. This problem. This should be, that was. Oh. So. So one. Has some. It ain't got an X in it. It's a sin. So, yeah. Watch out. Yes. We're kind of driven back long base 8. Anybody remember what this is? Here, the role of A is being played by 8. And actually, I could even do absolute value here. Also, in class. So if I go through this, A is A. Log base 8 of the absolute value of tangent x is 1 over tangent x times natural log 8. But I'm not done. I have to multiply. What's inside the parentheses? Yes.
So for inverse trigonometry, we need to know secant, sine.
Inverse sine, inverse cosine, inverse tangent. Those are the ones that I would keep fresh. Don't bust your brain cells up memorizing the other ones, because even if you do, it's not going to do you good. It's all in your ask you to try. I will ask you a question where it won't benefit you to already know. Yes.
It's, I did it.
Look,
It's wide for
okay, so let's see.
this was.
Oh, that's needs to be a lot of time. All right, because remember what you're doing here, you're taking the derivative of respect to x, right? And so the derivative, so what you have in it's secant squared y, which I agree with, y prime. And here you have x prime, but that's just 1. So you're a little bit off there.
I didn't have, I got that.
Oh, right. Use the above information transfer. Okay, so you're good this far. This is tangent y is x. This is 1 over a squared. That's how you do it. Remember, the tangent is x, change the square root of the square.
It's what I did. So. I'll be so we pull that, so we give it this. And so.
Are we talking about part C? Oh, we're talking, oh, okay.
So for the sign, that's right.
Oh, no. That's a big problem.
So the signs.
We need to go over this one, I think. Okay, suppose you're confronted with this on the, that's right. Can somebody look down the road and see what problem I'm gonna run into? I'm gonna run into a problem. Somebody tell me what the big problem here in this thing is. Ah, that's right. That's exactly right. Because our situation is, it's gonna start off easy enough, but you're gonna get to here and you've got a variable base and a variable exponent, right? Everybody agrees? So that is a future problem for this problem, right? Now, how do we deal with variable base and variable exponents? We take logs, right? That's not going to do any good at this point. Because log of sine, you're stuck, it doesn't help. How do you do this problem? Just freaking do it until you get stuck, right? Let me show you what I mean. I would literally do this. Just run this horse till it's out of gas. What is the root of sine of log? Go sine of log. Now, am I done? Now I've got to multiply by the derivative. What's the side here? And what do I come to? Come to the sine of log. Derivative of sine of log again. Cosine. Agree? Now I've got to multiply that by the derivative of what I find inside this chain, right? And what's the root of sine x and sine x? It's called, I don't know, right? I've run into my problem. So what I will literally do is this. Write this in colors so it can be dramatic. Times derivative of sine x to sine x power. Right? That is correct. You'd certainly get credit for this, but not complete credit because it's not correct. But well, it's not completely done. All right, it's a little bit incomplete. Do I agree with that? It's right so far. We'll literally do this. Aside. This is what I need to find the derivative of. Write this. There's your trouble. Tackle. Now I can take a log of this. Sine x to sine x, so I can do that. Okay. Now let's figure out the derivative of this. Y prime is equal to 1 over y prime cosine x log sine x plus sine x times 1 over sine x cosine x. Everybody see how I got that? Yes. You never ignore it. It's always, you always do the product. Right. Now let me point out. So how would you take the derivative of this? It's 1 sine x plus x times cosine, right? How would you take the derivative of this? Well, I mean, this is just 2 cosine X, right? But you can do the product rule if you like, still what I'm doing. It would be 0 times sine X plus 2 times cosine X, which is the same thing you get forever. So maybe you saw a problem where you had a constant from along, maybe. Right, but yeah, you always have to use the product rule. The product. Is everybody okay here? Yes.
So when we get to that point where it's one of the y that time, is it okay to leave it that way, or do you want us to solve the y?
Well, I want a little bit more here. I would say, notice by the way, these signs cancel. I would say y prime is y times this mess, which is, what is y? It is sine x to the sine x. There's your y, and your mess is cosine x log sine x plus cosine x. And this is what goes here. So indicate somewhere on your paper, you don't need to rewrite this whole thing over again unless you've got plenty of time on your hands. You don't have to do it, as long as you make clear that this piece of the puzzle is this down here, communicate it to me clearly, I'm totally okay with that. Okay. Does that help? Okay, other questions? After your tests are graded, which will be next day. By the way, probably after your test tomorrow, I'm probably just gonna go home and grade your papers, unless you stop me. Somebody needs to talk to me after class, that's perfectly okay. After you get your test back, what I'm probably gonna do is I'll have them graded tomorrow, and I'll put some stuff up on Canvas. Here's your quiz average, your current quiz average, blah, 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 here's where I think you're at now. You all have, Wednesday, Thursday, you have till the end of the week to have a meeting with me. You come have a meeting with me, and this will be true after every exam. You get 10 points on your test, right, added to them. So please take advantage of that. You don't have to schedule anything. Just come to my office, or I mean, you can schedule. Just come to my office during office hours. It doesn't have to take a long time, but I just want to sit with you and see where you're at, and just assess. Okay, other questions? Yes. So you're thinking, you're close. What's a little bit off is this. One over one plus log squared times root log root is. So I'm agreeing that here, there's one slight mistake here. This is actually but because when you square that, it's not as important. You're taking the yes. secant. The derivative of secant. It looks like we have the derivative of secant squared. Oh, yeah, I think the derivative of tangent, secant squared, the derivative of secant tangent, I think in this thing that was first. Because it looks to me like, so you did one of the block, the derivative block, which is the product of it. So you take the derivative of secant 4 first, so that's 4 secant cubed, I agree. Derivative of secant, which is actually secant tangent. And then it should be 2 tangent for 1, and derivative tangent of secant squared. And secant. I go first with the 4 log secant plus 2. Yes. Okay. Okay, so I'm going to interpret this. You know if that's cosine of the whole thing? Well, that's what let's drive off and then do, so let's try it. So I'm gonna write this. This is what the problem would be now. Cosine of secant of x. Okay. Oh, it's moving out. Yeah. This is it. Yeah, this is like kind of off. So we'll do it. Okay. Yeah, this was a deck on a hot plate, but you know, just go through what's the first thing you can. Something to the 1/3 power, 1/3 is blob. Minus 2/3. And there we have our first. Well, you're going to multiply this by the derivative of what we find inside. And let's see, what do I find inside here? I find a cosine. Derivative of cosine is sine of blob. Okay, so now I'm inside this chain. Derivative of cosine minus sine. Now I've got to multiply by, in fact, just so I don't lose myself. looks like I couldn't make it all the way through the marathon. I had to stop and take a little break here. So I didn't confuse myself. You can go on if you're a stronger person than I am, but I'm gonna stop here and do this. And now I'm gonna keep going with this, right? So I'll write the first part in blue and the rest in something else. Or you can do a little aside. Secant x squared equals 2x. X sine 2x squared minus 2/3 times negative sine secant x squared equals 2x over x sine 2x squared now. Let's do the rest of it. Yes. Bottom square. So far, so good, right? This might be rather audacious numerator. All right, so bottom comes through the top. What's through C? C. So I got to see this key.
Nothing to see.
So,
Since it's same inside.
right, exactly. Secant block his block, right? But I'm not done with this because we're going to multiply by the side. And that should be, this is a product of 2x equals 2x plus x squared and derivative of 2x. Minus top times the derivative of the bottom. Whatever that may be. The derivative of the bottom is product of what we change. So it's going to be 1 times sine 2x squared plus x cosine 2x squared. Come through what's inside, which is 4x. So it's nothing. I think that'll do it. One more big derivative. What's it now?
Once you realize it's like.
But again, with the chain rule, nothing super hard as far as derivatives. The worst thing I think you have to take derivative of is C. It's just, you gotta be careful about doing your account. Okay, other questions? Yes. Looks like we have EDX here, which is something that you want to do. But that's- which- Yeah. So it's not really clear what you're transferring. So this is function, right? So the first thing I'll do, you had this kind of show up in your problem. You handle it pretty well by doing this. Okay, okay. Okay, let me address that problem in a moment. I'm gonna go through and finish it. Do you know what the derivative is now? Okay, so that's good. So, all right, so let me go through another example of what to do in this study. So for this problem, so the answer in all its glory is this. What's the derivative of the inverse tangent of log? 1/1 plus log squared. That works out nicely. Times the derivative, what's inside the parentheses, which is 1/2 x squared plus 1 minus 1/2. Prove what's inside there, which is and again, you can leave it like this, but if you want to simplify this, this is simplifies it nicely. This is actually 1 + 1. And this is x square root of x squared. So that's actually goes to the okay, let's suppose that you encounter this problem like this. It's like suppose you problem is this. Here's the situation. That you encounter. Oh crap! I forgot what the derivative is. Right. It happened anyway. There's one thing. Derive it. Right? Okay. What do you do practice? Suppose that you're out of time, right? Don't see how to do this? Just a couple steps. Right. Derivative of tangent is secant squared. So this is secant squared y. Y prime 1. Y prime is 1 over secant squared y. 1 over tangent squared y plus 1. 1 over x squared. What do you practice? Suppose you don't have time to go out. You're running out of time. Simple. Here's literally what I would do. Listen. I don't know derivative of tangent inverse. numbers. So let it be little f of x. Right? So now y prime or ddx. What's the derivative inverse tangent of blob? F of blob. Right? And now multiply by the derivative of what's inside, which is, and hopefully we can do that, right? If I was stuck, I would literally do that. I don't remember what the derivative of inverse tangent, but if it's f of x, this is what I do. I plug square root of x squared plus 1 into the blob, and then do that. Right? Because now that demonstrates that the only missing piece of your puzzle is you forgot what the derivative of inverse tangent of x is, but you know how to do the rest of the change right. This what? X to the x. I'm going to do this quicker way and then a way that works more in general. I got that right, didn't I? Okay, we want to figure out the derivative. Okay, what kind of situation are we in here? I mean, what's the big fat clue that this is something that we've got to throw a lot at? Yeah, that's right. It's this tower thing. We got variable base, right? So one thing that we can do. And this allows me to bring down the exponent. Now be careful here. The exponent, this is the base, x by itself. The exponent is this. Now you still got a variable base, variable exponent. All right, so you can hit it with another. And this works here because everything's a product. This allows me to dig. This allows me to attack the second variable, variable. Yeah, no, my um, now, of course, this last bit allows me to bring down this. I've now got this stripped down. Look at the thing on the right. There's no variable base, variable. Now, so this dx this, take the derivative of this, derivative of log of blob, 1 over blob, derivative of what's inside, 1 over y, times what's inside y. Am I okay with that? And this is equal to the derivative of this, right? So let's go through this. First thing I come to the product here. I got this. The derivative of x squared plus 1 is 2x. And then I get x squared plus 1 times 1 over x, so I'll write it back. And then I've got this other chunk right here. 1 over log x. And so solving this problem, y prime is equal to y log y. So let's just do kind of here. Y prime. See, y was x, the x squared plus 1. Log y is x, the x squared plus 1. Log x. And my mess is 2x log x plus x squared plus 1 over x plus 1 over x log x. There's real power in the laws. Okay, any questions? You guys catch up. Oh, yes. Oh, this is. Yeah. No, it'd be 1 over blocks, one over that whole thing. That's derivative what's inside. What's inside is part of C and squared. Both of those change. That's right. Ln first plus Ln second, then bring down the exponents. You get 4 log C. Much easier. In fact, the other one is same. They'll look a little bit different, but the massage. Okay, everybody. In the theme of your question, let me give you another. How would you do this? Sine index x. Now, the log is not going to work immediately. This is very, again, literally, I would do this. Start taking derivatives and go as far as you. What's the first thing you come to if you're taking derivatives? sine of something, right? And so the derivative of that is cosine of that something. Times derivative of what's inside. Correct, but not. So I've got the first piece right. It's cosine of blob, derivative of blob. First and foremost, what is this? What do we got to put like this? Agreed. Product. So let's take another step of that DDX business. Okay, so let's go through this here. It's derivative of this. Plus I agree with that. Still correct, still incomplete. Right. So now I've got two smaller missing pieces of the puzzle. Right. These are my two missing pieces. Right. Everything else is. So literally, go over here. Go over here and let's figure out what number one and number two are. Number one. Y equals X. Now this was kind of blatantly got to throw along. So I get log Y. X. You guys see where I got that? I brought down. So when I take the derivative of both sides of this, 1 over y, y prime, derivative of this. Again, with product. What's the derivative of tangent? Tangent. So I get y prime, y times this, which is x tangent x power secant squared x log x tangent x. And this thing goes back in the points. Number two. Now let's let Z be something else. The tangent x, the x power. So log Z, x log tangent x. So 1 over Z C prime, taking the derivative. Log tangent x. Plus x 1 over tangent x. Secant squared. So C prime, C this equals tangent x to the x. And the mess is log tangent x plus x cotangent x secant squared x. And that goes in the middle. So that's what I would do when you can't just throw a log at it. It's like add it inside of somebody else's. Take derivatives until you run out of real estate and then you log. Yes. Sure. Yeah. Oh, workmanship clause. Okay. Okay. So just for reference, tell me where you got the problem. It's off an old exam.
2017.
2017, which is saying summer exam 2, number 3. Right? So let's make sure it's right. I've got a rectangular tank. Base is A by B rectangle. Height is H. Did I get all that right? Okay, so tell me the rest of the problem. It's leaking.
Has a leak in the bottom of the water. Has a leak in the bottom and the water is draining out.
Okay. Leak and bottom is draining water. At L cubic feet per second. So I'm going to assume all my dimensions are in feet, right? And what's it ask? How fast is the depth decreasing? Height of the water. By the way, what if L is 0? How fast should the water be decreasing? It's not. So actually, I expect a formula, but when I plug in L equals 0, I get 0. Right? Little things like this sometimes are very useful in working properly. So let's draw a picture of this. So what do I have here? I've got this A by B rectangle. And the height of the tank is H. And then that be perfect. The L. So we've got this tank, it's A by B by H, right? And it's got water in it. May not be filled up all the way to the top. In fact, I expect the water to be sort of leaking out. Here's the water. Apparently there's some sharks in it. So how deep is the water? Call it something. Let's call this capital D for how deep the water is. Right? So there's my beautiful picture. Got the aquarium. A by B by H. It's filled, it's got water in it, some depth D. All I know about that is it's certainly can't be more than H, right? It's got to be at least 0. So my picture's taking care about everything. And now there's something else. Another piece of information I need to take care of. What is that? The leak rate, right? So here comes a little drippy drip out of the bottom. Drip, drip, right? And this is L cubic feet per second. Now, I wrote the units down there because it's good of me to do that, but also it should tell me something. What is that leaking? Very close. It's a change in volume. Right? Because the cubic feet is the volume, and this is how fast it changes. So this is measuring the change. How fast it's leaking is how fast the crap's coming out of the aquarium. Everybody agree with that? So this L cubic feet per second is the change of the volume with respect to time. Or B is the volume of water. The change of the volume of water in the tank is equal to the leak rate. Am I agree with that? Okay, so this is one of those related rates thingies. The water in the tank is all this green stuff, right? And somebody give me a formula, related rates, we always need a formula. I know dV/dt, right? And what is how fast is the height of the, so what's the question here? D is this, right? Oftentimes in these problems we have at some time, but here we said that the rate of leakage was constant, right? So it doesn't matter. So it looks to me like I need a formula for volume with respect to D. You guys know what that is? So suppose I have a swimming pool, a very modest one, that is, let's say, 40 feet by 5 feet by 6 feet. How many, so I'll get 40 feet by 5 feet by 6 feet, that's a stupid little swimming pool, but we'll have it anyway. How much water does it take to fill that up? And where did you get that? Right, that's right. The base area of that is 200 square feet, right? 6 high. Maybe the volume. Now look at this piece here. What's the volume of the water that's in that tank? A times B times how deep it is this right. Volume is A, B, By the way, only one of those three variables on the right side is really a variable. Which one? Throughout the problem, does A change? D is the only one that's variable, right? Your aquarium is not changing. The A, the B, the H does not change. The D does change. Water or potentially change. Water moves that. Take a derivative of this. And I get dV, dt. Notice this is a constant, so different than 2. Right? A, B, capital D. And by the way, A should be measured in feet, B is measured in feet. This is measured in cubic feet per second. And this is equal to L. Because this is D2. So L over AB. And this is in feet per second. That should be. Notice that when L is 0, we get that it's not changing by which is what we did. Okay. Any questions? Get used to it because you and let me give a plug for numbers. What's 265.538 from 50,678? Anybody know? Okay. What's A times B? AB. It's so much easier. Nobody was and not only that, instead of putting sitting there, we do AB, you can infinitely many problems at once. Right? And that's why people like to do these in terms of formulas, because once you solve the problem, you often solve infinitely many problems. That's something that you can use. Okay, other question. Yes. Oh, this is okay, right. I think I'm talking about. So you okay? Yes. Yeah.
Check.
Music and the flag. That makes sense. Other questions? I think all our next review session probably be Tuesdays. And some of them, I might have to have it later, like 5 o'clock or something like that, but we'll see. I prefer to do it at this time. But I'll let you know as that. Are you guys studying tonight? Okay, instead of like seriously, I think you're much better than freshman. Yes. Drop. Oh, we're taking the derivative of this one right here. Oh, so you rewrote it, right? Okay, so you put 4 log C. that was good. Might try to do it the masochistic way. It's a mess, and you should simplify it. That's a good judge.
Right. That's-
In my opinion, I'm glad you see what it is. So, yeah, I think it's like Bear said, swimming. I always make it my test is low, then I. Stay up, break down. Anyway, answer everything, do your best. I know this is part of life, try to have some fun. That's- You're welcome. Good thing.